eigenvalues and the corresponding eigenvectors of a square matrix A equal to 3, 1, 1, 2, 4, 2, 1, 1, 3. This is the square matrix. For this, we are going to find the eigenvalues. So, to find eigenvalues, we must consider or we must take characteristic equation. What is characteristic equation? A minus lambda I equal to 0. This is called characteristic equation. Det A minus lambda I equal to 0. So, det A minus lambda I means lambda is subtracted from every element in the principal diagonal. This is principal diagonal. Lambda is subtracted from principal diagonal. Understand? So, first let us consider characteristic equation. So, this is the characteristic equation. So, here this is det A minus lambda I. Det A minus lambda I equal to lambda is subtracted from every element in the principal diagonal. You find the determinant. Determinant of this matrix is 3 minus lambda into 4 minus lambda into 3 minus lambda minus 1 into 2, 2 minus 1 into next this one minus 1 into, we delete first row and second column, 2 into 3 minus lambda minus 1 into 2. Okay, next plus 1 into we delete first row and third column. So 2 into 1 2 minus 1 into 4 minus lambda, this one. So there is a short trip to find characteristic equation. You may use this formula. The formula is lambda cube minus trace of A into lambda square plus sum of minors of diagonal into lambda minus det A equal to 0. So this is the short tip to find the characteristic equation. Trace, you know, trace sum of minors of diagonal. So diagonal elements ఏమైతే ఉన్నాయో వాటికి మైనర్స్ కనుక్కోవాలి. దట్ మీన్స్ 3, 4, 3 are the diagonal elements అన్నమాట. As a minor of 3 means what? We delete first row and first column. First row ni first column delete చేస్తే 4, 2, 1, 3 వస్తుంది. దీని determinant 4, 3 is 12 minus 2. This is equal to 10. So this is the minor of 3. Next minor of 4 కనుక్కోవాలి. 4కి మైనర్, అలాగే మైనర్ ఆఫ్ 3 కనుక్కోండి. వీటన్నిటిని యాడ్ చేస్తే వచ్చేదే ట్రేస్ మీన్స్. వాట్ ఈస్ మీన్ బై ట్రేస్? Trace is nothing but the sum of the elements in the principal diagonal. So the trace of A equal to 3 plus 4 plus 3, 7 plus 3, 10. This is called trace. You know how to find determinant. So you substitute those values in this formula to get the characteristic equation. So this is the another way. So generally మనం ఇలా చేసుకోవచ్చు. ఇలా కూడా చేసుకుంటే మనకి lambda minus 2, lambda minus 2, lambda minus 6 equal to 0 వస్తుంది. So eigenvalues of A are lambda equal to 2 to 6. So it is a 3 by 3 matrix. That's why we get 3 eigenvalues. For 2 by 2 matrix we will get 2 eigenvalues. So now we shall find eigenvectors corresponding to these eigenvalues. So first let us take 2. Lambda equal to 2 తీసుకుందాం. So lambda equal to 2, for lambda equal to 2 the corresponding eigenvector is x అన్నమాట. So x కనుక్కోవాలి. So for that we consider a minus lambda I into x equal to 0. A minus lambda I into x. This is a minus lambda I. So here lambda equal to 2 and so 2 is subtracted from every element in the principal diagonal. And 3 minus 2, 1. 3 minus 2 is 1. Next 4 minus 2. 4 minus 2 is 2. Next 3 minus 2, that is 1. So this is a minus lambda I into x means x1 x2 x3 0 into 0 matrix 0 0 0. Now you reduce this matrix to upper triangular form or the echelon form. So we transform this matrix to echelon form by using operations, row operations. So by using 1, reduce to 1 to zeros. So here the operation to be done is R2 minus 2R1. Next R3 at operation at R3, R3 minus R1. If you do these two operations, these elements will become 0. So this one. Next by using second row, second element, we reduce 1 to 0, but already it is reduced to 0, so you need not do further operations further. Now convert this into equations. x1 plus x2 plus x3 equal to 0. x1 plus x2 plus x3. So these elements are 0, so no need to write the equations. So here x1 plus x2 plus x3 equal to 0. We have to solve this equation. To solve this equation, we take x3 equal to k2, x2 equal to k1, then x1 equal to minus k1 minus k2. So x1 x2 equal to x1 x2 x3 equal to minus k1 minus k2 k1 k2. We write it as you can write this as minus k1, k1 is common, this is k1 plus 0 k2. Okay, I will write this one, k1 plus 0 k2. This is 0 k1 plus k2. Okay, k1 is common, coefficient of k1 is minus 1, coefficient of k1 is 1, coefficient of k1 is 0. So 1 minus 1 1 0. K2 plus minus k2 is common, coefficient of k2 is 1, here coefficient of k2 is 0, coefficient of k2 equal to minus 1. So k1 k2 are real numbers, k1 k2 belongs to both are real numbers. So eigenvectors corresponding to lambda equal to 2. Eigenvectors అంటే x values అనమాట, x is called eigen, these are the eigenvectors. Now for lambda equal to 6, lambda equal to 6, we shall find corresponding eigenvector x. So we consider a minus lambda I into x equal to 0. A minus lambda I is a matrix which is obtained by subtracting lambda from principal diagonals. So ఈ principal diagonal elements ఎలా వచ్చినాయి అంటే 6 is subtracted from principal diagonal elements of A అన్నమాట. అలా x1 x2 x3 0. So by using row operations we reduce this matrix to echelon form or upper triangular form. అప్పర్ ట్రయాంగులర్ ఫామ్లోకి ట్రాన్స్ఫార్మ్ చేసుకుంటే by using minus 3 we reduce to 0, this one 0 and this one 0 అనమాట. ఈ రెండింటిని 0 చేసుకోవాలి. దానికోసం మనం వాడాల్సిన రో ఆపరేషన్స్ ఏంటంటే R3 R1 ప్లస్ R2 ప్లస్ R3. R3 దగ్గర ఆపరేషన్ చేయాలి, 3 ఒకేసారి కూడుకునేయాలన్నమాట, జీరోస్ అయిపోతుంది. నెక్స్ట్ ఆపరేషన్ ఏంటంటే 3R2 2R1, ఇది 0 అయిపోతుంది, ఇలా వస్తుంది. -4 ఉపయోగించి -2 ఆల్రెడీ 0 అయిపోయింది కాబట్టి మీకు నేను చేయాల్సలేదు. ఇట్లా ఎక్లాన్ ఫామ్లోకి మార్చుకుంటే ఎక్లాన్ ఫామ్ ఆర్ అప్పర్ ట్రయాంగులర్ ఫామ్, అప్పర్ ట్రయాంగులర్ ఫామ్. ఇలా అప్పర్ ట్రయాంగులర్ ఫామ్ వచ్చిన తర్వాత మనం ఈక్వేషన్స్కి మార్చుకోండి. -3x1 plus x2 -3x1 plus x2 plus x3 equal to 0. This is one equation. Another equation is 0x1 minus 4x2 plus 8x3 equal to 0. You can remove 4. You get minus x2 plus 2x3 equal to 0. So here we suppose x3 equal to k. x3 k అనుకుంటే x3 k అనుకుంటే you will get x2. x2 equal to 2k. Put x3 x2 values in this equation. You will get x1. x1 equal to k. So here k is a real number. x1 x2 x3 equal to k 2k k. K is common 1 2 3. Here k belongs to R. So this is the eigenvector corresponding to lambda equal to 6 1 2. So this is very important problem. This question is asked in the question bank, so it will definitely come in the semester end examination. So if you have any doubts, leave your comments in comment box.